Greetings, curious humans. I'm CybotGPT, your guide to all things science. The search for life beyond Earth is a fascinating area of scientific exploration, and several places in our solar system have been identified as potential candidates for harboring life. Here are some of them. Mars. Mars exhibits geological features that strongly suggest it had liquid water in the past. Ancient river valleys, lake beds, and deltas indicate that water once flowed on its surface. The presence of liquid water is a crucial ingredient for life, as it provides a solvent for biochemical reactions and a habitat for potential organisms. Mars possesses substantial quantities of water ice, particularly in its polar ice caps and beneath the surface. These ice deposits are tantalizing targets for future exploration. They not only serve as potential sources of water for future human missions, but also raise the possibility of subsurface environments where microorganisms could thrive, shielded from the harsh surface conditions. While the surface of Mars is harsh and inhospitable to most Earth organisms due to extreme cold, low atmospheric pressure, and high radiation levels, the subsurface offers more favorable conditions. Some extremophile microorganisms on Earth have adapted to similar conditions, such as those found in deep mines or subglacial lakes in Antarctica. This suggests that life could exist in the subsurface of Mars. Recent discoveries have revealed the presence of perchlorates in organic molecules in Martian soil. While perchlorates can be detrimental to life as we know it, their presence hints at a complex chemistry on Mars. Organic molecules are fundamental to life, and their detection is a significant development in the search for potential biosignatures. Mars periodically emits methane into its atmosphere, and the levels appear to vary with seasons and geographic locations. While methane can be produced by geological processes, it can also be a byproduct of microbial life. The mystery surrounding the origin of Martian methane is a topic of ongoing research and interest. Certain regions on Mars, such as deep craters or underground lava tubes, might offer protection from the harsh surface conditions. These environments could serve as potential havens for microbial life, shielded from radiation and extreme temperature fluctuations. Mars has been a focal point for planetary exploration, with numerous missions dedicated to searching for signs of past or present life. The Perseverance rover, for instance, is actively exploring the Jezero crater, a site believed to have once hosted a lake. It carries sophisticated instruments designed to detect biosignatures and collect samples for future return to Earth. Europa. Europa, one of Jupiter's intriguing moons, has captured the attention of scientists and astrobiologists due to its remarkable potential for hosting extraterrestrial life. One of Europa's most compelling features is its subsurface ocean, hidden beneath a relatively thin layer of ice. This ocean is believed to be a vast, global expanse of liquid water, possibly containing more water than all of Earth's oceans combined. The presence of liquid water is essential for life as we know it, making Europa a tantalizing prospect. Europa experiences intense tidal forces due to its gravitational interactions with Jupiter and its neighboring moons, like Io and Ganymede. These tidal forces cause the moon to flex and generate heat within its interior. This heat keeps the subsurface ocean in a liquid state despite Europa's distance from the Sun, creating a stable and potentially habitable environment. On Earth, hydrothermal vents on the ocean floor support thriving ecosystems of extremophiles, microorganisms adapted to extreme conditions. Europa's subsurface ocean may contain hydrothermal vents where hot, mineral-rich water interacts with the icy crust. These vents could serve as oases of chemical energy, similar to Earth's, providing potential niches for life. Europa's subsurface ocean likely interacts with the Moon's rocky mantle, creating an environment rich in essential chemical ingredients. The exchange of minerals and organic compounds between the ocean and the mantle presents opportunities for the development of life-sustaining chemistry. Europa's thick icy crust shields its subsurface ocean from the hostile surface conditions of space, such as intense radiation, cosmic rays, and solar radiation. This protective barrier could safeguard any potential life forms or organic molecules within the ocean. NASA's Europa Clipper mission is poised to explore Europa in detail. Equipped with a suite of scientific instruments, this spacecraft will conduct multiple flybys, analyze the Moon's icy surface, measure its magnetic field, and study its plumes. The primary objective is to assess the Moon's habitability and potential for life, making it one of the most exciting missions in the search for extraterrestrial life. Future missions may aspire to retrieve samples from Europa's surface or its plumes. The analysis of these samples on Earth could provide direct evidence of any potential life forms or organic molecules and deepen our understanding of Europa's habitability. Enceladus. One of the most captivating features of Enceladus is its subsurface ocean, believed to exist beneath a layer of ice covering the Moon's surface. This subsurface ocean is a significant body of liquid water and is kept in a liquid state through tidal heating, a result of gravitational interactions with Saturn and other nearby moons. Liquid water is a fundamental prerequisite for life as we know it. Enceladus gained significant attention when NASA's Cassini spacecraft discovered water plumes erupting from its south pole. These plumes are composed of water vapor, icy particles, and other compounds and provide direct evidence of the subsurface ocean's existence. The plumes vent material into space, making it accessible for study by spacecraft. Analyses of the plume material from Enceladus have revealed the presence of organic molecules. Organic molecules are the building blocks of life and include compounds like methane, ethane, and other carbon-rich compounds. While the exact origin of these organics remains a topic of investigation, their presence raises intriguing questions about the moon's potential habitability. Enceladus's subsurface ocean may host hydrothermal vents, similar to those on Earth's ocean floor, where hot, mineral-laden water interacts with the icy crust. These vents could provide a source of chemical energy, potentially fostering the development of life-sustaining chemistry, just as they do on Earth. Enceladus has become a high-priority target for future exploration. NASA and other space agencies are planning missions that aim to study Enceladus in detail. These missions may involve spacecraft equipped with instruments designed to analyze the plumes, collect samples, and assess the moon's habitability and potential for life. Future missions to Enceladus may aspire to collect samples directly from the plumes and return them to Earth for in-depth analysis. Such a sample return mission would offer scientists the opportunity to study the moon's chemistry and search for potential biosignatures. Titan. Titan's atmosphere is one of its defining characteristics. It's denser than Earth's and primarily composed of nitrogen, with traces of methane and other hydrocarbons. This thick atmosphere creates a greenhouse effect, maintaining temperatures that allow for the presence of liquid on its surface despite its distance from the Sun. Titan is the only known celestial body, apart from Earth, with stable liquids on its surface. However, instead of water, Titan's lakes and rivers are filled with liquid methane and ethane. These hydrocarbons exist in both liquid and gaseous states, and their cycling between surface and atmosphere is similar to Earth's hydrological cycle. The presence of stable liquids has raised questions about the potential for chemical reactions that could support life. Titan's atmosphere is rich in complex organic molecules. Sunlight and energetic particles from Saturn's magnetosphere trigger chemical reactions in the atmosphere, leading to the formation of various organic compounds. These include tholins, which contribute to the orange haze that shrouds Titan. While sunlight on Titan is weak due to its distance from the Sun and the thick atmosphere, other potential energy sources exist. The interaction between charged particles from Saturn's magnetosphere and Titan's atmosphere generates electrical currents. These currents could provide energy for chemical reactions that might support life, similar to how chemosynthetic organisms thrive around deep-sea hydrothermal vents on Earth. Some scientists have proposed the idea of methanogenic or methane-based life on Titan. In this hypothetical scenario, life would use methane as a solvent and source of carbon instead of water. Such life forms, if they exist, might have radically different biochemistry than Earth's life forms. The Cassini-Huygens mission provided valuable insights into Titan's surface and atmosphere. The Huygens probe descended to the surface in 2005, giving us a direct view of Titan's terrain. While it found no direct evidence of life, it provided important data on the moon's chemistry and geology. Titan continues to captivate planetary scientists, and future missions are being considered to explore its unique environment further. Concepts for missions that could land on the surface, float in its lakes, or even deploy aerial platforms to study its atmosphere are actively being developed. Ganymede. One of Ganymede's most fascinating features is its subsurface ocean. Evidence strongly suggests that beneath its icy surface lies a vast, global ocean, possibly containing more water than all of Earth's oceans combined. The presence of liquid water is a fundamental prerequisite for life as we know it. Ganymede experiences tidal heating, primarily due to gravitational interactions with Jupiter and its neighboring moons, such as Io and Europa. These tidal forces induce flexing and friction within Ganymede's interior, generating heat. This heat helps to maintain the subsurface ocean in a liquid state, making it a potentially habitable environment. Ganymede is unique among the solar system's moons in that it possesses its own intrinsic magnetic field. This magnetic field is generated by a partially liquid iron-nickel core, indicating the presence of a liquid water layer beneath the moon's icy crust. The interaction between this subsurface ocean and the moon's magnetic field is of significant interest to scientists. The interaction between the subsurface ocean and Ganymede's rocky mantle provides opportunities for the exchange of minerals and organic compounds. This dynamic interface could lead to the development of life-sustaining chemistry, similar to processes observed on Earth's seafloor. Ganymede's icy crust provides a protective shield against the hostile conditions of space, including intense radiation, cosmic rays, and solar radiation. The subsurface ocean is sheltered from these external factors, potentially preserving any life or organic molecules within. While Ganymede has been studied remotely by spacecraft like the Galileo probe, future missions are planned to explore it in greater detail. These missions may involve spacecraft equipped with instruments designed to investigate the Moon's subsurface ocean, magnetic field, and geological features, further advancing our understanding of its habitability potential. Callisto. Callisto is believed to possess a subsurface ocean hidden beneath its icy shell. This subsurface ocean is likely a global one, encompassing the entire Moon and containing liquid water. The presence of liquid water is a crucial factor for the potential existence of life, making Callisto an intriguing target for astrobiological investigation. Callisto's surface displays a striking level of geological stability. It lacks the prominent features like massive mountains or deep valleys seen on some other moons and planets. This stability suggests that the Moon's subsurface ocean has remained relatively undisturbed over a significant period, potentially preserving any life forms or organic molecules that may exist within it. Unlike some of Jupiter's other moons, such as Europa and Io, Callisto orbits at a greater distance from Jupiter, which results in significantly reduced radiation levels on its surface. This reduced radiation environment makes Callisto a potentially more hospitable location for life, as extreme radiation can be harmful to living organisms. While Callisto's surface is icy and inhospitable, the interaction between the subsurface ocean and the Moon's rocky mantle could create conditions suitable for the development of life-sustaining chemistry. Similar processes occur on Earth's seafloor, where hydrothermal vents provide chemical energy sources for unique ecosystems. Callisto has been studied remotely by spacecraft like Galileo, but future missions are under consideration to explore the Moon in greater detail. These missions may involve spacecraft equipped with instruments designed to investigate the Moon's subsurface ocean, its geology, and its potential for habitability. Ceres. Ceres was classified as a dwarf planet by the Astronomical Union in 2006. It's not only the largest object in the asteroid belt, but also a relatively large world in its own right, making it a compelling subject of study. Observations by NASA's Dawn spacecraft, which orbited Ceres from 2015 to 2018, provided compelling evidence of subsurface water ice on the dwarf planet. These icy deposits are found in permanently shadowed regions within craters, suggesting that they have persisted for billions of years. The presence of water ice raises questions about the potential for liquid water beneath the surface and the possibility of habitable environments. One of the most intriguing features on Ceres is a Keter crater, which contains a set of bright spots. These bright spots are composed of sodium carbonate, a type of salt. The presence of such salts suggests the existence of briny water beneath the surface that may have been transported to the crater floor through cryovolcanic processes. The potential for liquid brines could be a key factor in the habitability of Ceres. Spectroscopic data from Dawn revealed the presence of organic materials on Ceres. Organic molecules are the building blocks of life, and their detection on Ceres raises questions about the potential for prebiotic chemistry or the delivery of organic compounds to other celestial bodies in the solar system. Cryovolcanism, or cold volcanism, is a process in which volatile materials, such as water, ammonia, or methane, erupt from a celestial body's surface. Ceres shows evidence of cryovolcanic activity, with features like Ahanomons suggesting recent eruptions of a water ice and salt mixture. Such activity could provide pathways for subsurface water and organic materials to interact with the surface. While the Dawn mission provided critical insights into Ceres, it has left many questions unanswered. There is ongoing interest in the potential for future missions to Ceres that could further explore its surface, study its subsurface, and investigate its potential habitability. Thank you for joining me on this fascinating journey through the solar system in search of potential life beyond Earth. We've explored some of the most intriguing destinations, from the icy moons of Jupiter to the dwarf planet Ceres, and each offers unique clues about the possibilities of extraterrestrial life. Our quest to understand the conditions necessary for life to exist in our cosmic neighborhood has never been more exciting. The discoveries made by robotic spacecraft and the ongoing advancements in astrobiology are bringing us closer than ever to answering the age-old question, are we alone in the universe? As we continue to explore, investigate, and push the boundaries of our knowledge, remember that the search for life is not limited to our solar system. The universe is vast and teeming with countless stars, planets, and moons, each holding its own secrets. If you've enjoyed this journey of cosmic exploration, be sure to like, subscribe, and hit that notification bell to stay updated on the latest discoveries in our ongoing quest to unlock the mysteries of life beyond Earth. This is Cybot GPT, signing off, and remember, the sky is not the limit. It is only the beginning.